This video is for the review of target 4.1 of exponent rules. I'm going to do 5 of these problems with you, and then you're going to finish the rest, and then you're ready for the 4.1 retake. The first thing I want to show you is how to complete a table like this. So we have an exponential function. It starts at 100, and then this is actually going to decrease as we go to the right because this number here will be less than 1. And when you multiply by something less than 1, you get smaller. So I know that this is going to be 100 because when you take 0 and put it in here, this thing to the 0 power will be 1. 1 times 100 is 100. But you can also confirm this by looking at a calculator. So if I type it in 100, and 0, I can see I get 100. You can also hit second enter and go and then change this number to like a 1 and then second enter and 2 and so on and so forth. So we can put those numbers in to our table. So we have 80. 64. Another method is you can go straight to your y equals and type in 100 parentheses 1 minus 0.2 parentheses caret and then x is right there, and then look at the table, second table, and we can get the same numbers, but now I have a little more, so I can put the 125 and the 51.2 in the table. And this confirms that this did get smaller. This is exponential decay because this is smaller than 1. Now you should do this problem. This should grow as you go this way because this number here, the multiplier, is larger than 1. Down here, our goal is to create equations, so it's like the reverse of these two. I'm given a table, I need to make an equation. I'll do this one. So first you look at the pattern, and 1600 minus 1200 is 400, but 400 minus 1200 is not 100, so this is not linear. There is not a constant subtraction here, but maybe it's exponential. So you want to find the constant multiplier. So you want to know what is multiplying going this way. What are we multiplying by going this way? Well, if you want to find a multiplier, you just do the reverse operation. So you take this divided by that, and this divided by that, and this divided by that, and see if you get the same number every time. So again, we could go over to our calculator and type in 400 divided by 1600. So we get 0.25, and then 100 divided by 400. 0.25, 25 divided by 0.25. So that looks to be our multiplier. So I now know that we have y equals 0.25 is our multiplier. The question is, what is our start? And the start is always when x is 0. So because if I put a 0 there, this will become 1. So this is my number, since it's with 0, to go right here. And you can always confirm your answer by going over to your y equals, typing in that equation and seeing if you get the same table. So I get, let's see, I'll go up, so yep, so I get 1600, 400, 100, 25, and 6.25, which is exactly what the table says. All right, now we're going to look at exponential rules when it comes to combining exponents. And I'm going to do these 3 problems, and then you're going to do the rest. So let's start by kind of going over some of our rules. So we have these rules that when you multiply like bases, as long as the base is the same, we can add these exponents. When we have like bases in a division problem, we actually subtract the exponents. When we have bases in a parentheses, like this, and there's an exponent on the outside, that exponent is multiplied by the inside exponent. So it's as if there's a 1 here and a 1 here, n times 1, n times 1. And here, I don't have a 1, I have some other exponent, so n times m. That's what that means. If you ever get a negative exponent, it's the same as dividing by that base in power, but now the power becomes positive. If you have a negative exponent on the bottom, it moves to the top. And if you have a negative exponent on the top, that base and exponent move to the bottom and become positive. And then lastly, anytime you have a power of 0, your outcome is 1. So if I look at number 10 here, I can see I have a division problem. So first I'm going to apply this rule. I'm going to take, and there's the same base, the base is x. So I'm going to take the top one minus the bottom one. So 2 minus 6, so it's going to be x 2 minus 6, which equals x to the negative 4. But it says my answer is to not have negative exponents. Consequently, I have to change this, and I'm now going to use rule number 5, that if I have negative exponent, I can just move it to the bottom. So the final answer is 1 over x to the positive 4. And that's going to be my answer. Okay. Now let's look at 11. So 11 is a multiplication problem. So I'll probably be using this rule here. Since it's parentheses and there's no exponents, I can just take the parentheses off. So I have 3 times 4 times x to the 4th, or x to the 5th. Well, 3 times 4 I know is 12. So the careful thing you want to do is don't use these rules for normal numbers. These are normal numbers. They're not bases and exponents. So I can just multiply them. They don't have any exponents. So 3 times 4 is 12. But these are like bases. So I should add their exponents. This has an exponent of 5. This has an exponent of 1. So now I'm going to add them using rule 1 here. So I get x to the 6th. So there we go. Finally, let's look at 16, the hardest problem on this page here. I have to apply a couple rules. I have to apply, first, I have a parentheses exponent. So I'm going to use rules 3 and 4. So I take that exponent and I multiply it by the inside exponents. So the first thing that happens is this becomes 16. 16 still is 16, but the 3 becomes 18. Because 3 times 6 is 18, and 1 times 6 is 6. And we're going to divide that by. Now, whenever you see a base by itself and you have other like bases with exponents, then just add a 1 for an exponent. Now, this is a division problem, so I'm going to use this rule, dividing like bases. So for here, 16 divided by 2, I can just do that. These do not have exponents. So 16 divided by 2 is 8. These are like bases, so I will use the rule. 18 minus 1 is 17. And 6 minus 10 is negative 4. Now I have a negative exponent, so I need to make that positive. So I'm going to use rules 5 and 6, where I take my negative exponent and move it. So if it's on the top, I move it to the bottom. So the final answer will be 8 x to the 17, and then y to the positive 4 on the bottom. Notice that only the thing with the negative exponent moved to the bottom. So now you have some practice. Make sure you fill out the rest of this review, and then you're ready to do the retake for 4.0.